Hi class, I'm gonna discuss Appendix A3 today in page 636, namely the Gauss-Jordan reduction. Right? What is it? Why we need it? Wait a minute. I'm gonna remind you something that we did last time. After that, I'm gonna discuss today's topic. All right. In Appendix A2, in my last video, I discussed how to solve this system of equations with two equations. So our problem is basically solving system of equations. So we consider a system with two equations. Even last time I told you we know how to do this algebraically. We can subtract one from the other and get x, then substituting we can find y. That's a different story. Why we do this? Our goal is to go for systems of equations with higher number of equations with many variables, right? For instance, 4 equations with 4 unknowns, 5 equations with 5 unknowns, 10 with 10 unknowns, likewise, right? If we get such a system, we cannot simply do it the way you guys know already, right? So last time this is what we did. We get the coefficient matrix and xy as a column vector equal to this we put as a column vector too. Then this is like a x equal to c. Now then we showed we can solve this. When we solve this, we get x equals a inverse c. There we found, I gave you this equation to find inverse matrix of A. It is 1 over determinant A times V. Interchange this and we change sign of these two, and when we reduce it, we get this. This is the inverse matrix of A. After that, we can substitute that A inverse here, and C is this. When we multiply them together, we learned how to multiply two matrices last time. Yes, we learned that by multiplying we can find x, which is our answer. X is again x and xy both. So this x is not this x, this is, I would rather write capital X. This x represents this column vector xy both. Once we find this, when we multiply these two, we get another column vector like this. We did that last time. With that we can find x and y, right? Now what we're going to do today is we're going to learn a different method. Why we need a different method? With this method, it's restricted. We are restricted to system with two equations with two unknowns. Why? Because when we have three equations with three unknowns, if we have three unknowns, we have to have three equations. Then we get 3 by 3 matrix here, right? Then when we move on to this step, we don't know how to find the inverse matrix, right? That is one of the reasons. So we need a different method. Let me erase this and move on to that, the new method. We're gonna use a two equations again. Plus 2y equal to 7 and 2x minus 3y equal to negative 4. We can, like before, we can write this system as 3 to 2 negative 3 xy equal to 7 negative 4. So this is like A, this is like x, equal to B. Right now here we make different thing called augmented matrix. Means we take this and this as well into a single matrix, three to 2 negative 3, and we separated that with a vertical line, 7 negative 4. Right, so this is like equal sign. Right, now when we write this matrix is a not like this matrix A. This matrix is a equation, right? Matrix form of the equations. Matrix form of these two equations is now this, right? Now we can, this is our A and this part is our B, therefore we can write this as simply A B. Clear? This is A, this is B, so our matrix is this. We call this augmented matrix. Augmented matrix. So when we use symbols A and B, this is the augmented matrix, right? Now now this represents this system. This thing represents this whole system. I'm gonna write in erase this part and write this here. Now it should be clear to you when we write this. This represents this whole thing, right? This whole thing is now here. Then what we do is this. We saw that this means, let's write this back in equation, matrix equation form. AX, this means AX equal to B. Right. Now let me find a different color marker. Now I'm gonna multiply both sides by A inverse. Multiply this side by A inverse and this side by A inverse. Then what we get? A inverse times A is what? This is identity matrix. I inverse matrix of a matrix times itself gives us identity matrix times X gives us A inverse B. We write this A clearly. A inverse B. So IX equal to A inverse times B. Now A inverse is a matrix, B is this stand for this column vector. When we multiply them, we again get a matrix. Let me erase this, I got that here. So for this, let's give a letter C. Now we have IX equal to C. Right. Now in short, what this means is, okay, before that let's again write this as augmented matrix. This is what I see. Right. Now if you compare these two, we can say that if we can find a way to convert A, B, if we can convert this to IC, then what can we say? C, from C we can find the answer. C gives us the answer. So look at the big picture. A times B. B was this. This was our B. Remember 7 and negative 4. I write it here. B stands for 7, negative 4. This is B. If we convert this AB system, this one to IC, in short, we just have to focus on this. If we convert A to I, means A to its corresponding identity matrix, on the other side we can find the answer, right? Means answer for X. Once we get X, we know how to find simple X and simple Y, right? What we have to do, I write this again here. AB system, case 3 2 2 negative 3. I'm writing this A B. B is 7 negative 4. If we convert this into corresponding identity matrix, which is 1 0 0 1, from some means, right? When we convert this according to this, these two will change, right? These numbers will change. We don't know what. Let me see if I can give you the answer. Two, three, two. Three, two, 2 negative 3 equals negative 4. Yeah, it was 1 2, but at the moment we don't know this. This is what we have to find. I put a question mark. This is 1 2 ultimately. I put question mark here and question mark here. Right. Means if we can do something to convert this part to its corresponding identity matrix on the right side, we get the answer. At the moment we don't know the answer, so I put question mark, right? So what is the way we do it? That is, for that we use this Gauss-Jordan reduction method to reduce this matrix to this matrix. How we do it? We're gonna see it now. So do you have to know all this? No, you don't have to remember this. You don't have to show this. All you have to do is, once you get the system, make this augmented matrix. From this, write the augmented matrix, then convert this part into its corresponding identity matrix. When we convert this, these two will change. Then this is our answer, right? So you don't have to know this part. I just explain you the theory behind, right? I'm gonna erase this. I keep this what we have to, so I copy this here. Copy this here. 3 2 2 negative 3 7 negative 4. Right. We want to convert this into 1 0 0 1 and find these two, right? Now for this we have to do matrix operations. It is in the book. I tell you the page number in a minute. I write it here, but I explain when I'm doing it. I'm gonna explain this. These are the allowed row operations. Still, we did not get into what Gauss-Jordan reduction means. I'm gonna show you next. There are three basic row operations. Swapping any two rows of the augmented matrix. Swapping any two rows of this. So remember, this is just two. We can get 3, 4, 5. Then in that case, we can interchange any of two rows. Multiply every entry in a row by non-zero constant. Multiply constant not equal to 0. If we multiply by 0, the whole row will get 0. So we can multiply all entries, every entry in a row by any constant, but not 0. Adding multiple of for these things in page 638. Right. So do you have to read this and memorize? No, you don't have to. When we doing it, you will automatically understand this, I guarantee. Right. So if you want, write them in your short note, but when we do it, you will understand what it means. So the Gauss-Jordan reduction, it used these operations. Right. Now I'm gonna read these steps of Gauss-Jordan reduction algorithm. It said maybe you won't understand, right? I'm gonna do problems. You don't have to memorize again. Do not try to memorize. If you try to memorize, you confuse yourself. Construct the augmented matrix from the given system of equation. We know that already. This is that. Then choose any diagonal entry from the coefficient matrix. Coefficient matrix. Now understand these things. Coefficient matrix is this, right? Its diagonal is this. When it's a diagonal, definitely it is this, right? Choose any diagonal entry. That means in this case this or this. If we have many lines, the whole thing along the diagonal. Remember, coefficient matrix is always square matrix. Why? If you have two variables, you should have three equations. If you have four variables, four equations, right? Therefore coefficient matrix is always a square matrix. Then always we have a diagonal. Choose any diagonal entry from the coefficient matrix portion of the augmented matrix, not yet selected. So don't worry about that part. Means if you shouldn't select entry that you already selected, right? You will understand when we do an example. Then convert that to 1. Okay. From in diagonal we have two elements here. Assume we decide to make this 1. So what we have to do, we have to divide this by 3. These are the important points. We have to divide this by 3. For that, what we should do is, according to this row operation, we have to follow these. We can divide entire row by 3, not just this element by 3. Right? We can divide entire row by 3. When you do couple of questions, you remember these steps. So when we divide entire row by 3, this will become 1. This will change accordingly. Do not focus on that, focus only on this. Then once you convert that into 1, that is called the pivot. Right? Pivot means something main, to something important or superior. So the row where the pivot element contains is the pivot row, and the column where the pivot element contains is the pivot column. Again, these terminologies are not too important. You just have to understand the concept and the method. Okay. Use the pivot leading one. In our example, say this. Now assume we convert it into 1, right? From the preceding step, to eliminate all non-zero entries in its column, called the pivotal column, if the left hand side of the modified augmented matrix is the identity matrix, the reduction is complete. Otherwise, go to step 2. Alright. That means first we make one of the diagonal element 1, right? Then that is the we call this the pivot pivot element. Then pivot row, pivot column. Make all entries in the pivot column 0. For that we use these operations, right? Then after we make them 0, go to another diagonal element which is not selected. If you select this one, do not go back to that. You go to this one, then make this is 1, and then make the whole column other elements 0, right? This first time this is the pivot element. Next time if you select this one, you make this is 1. How? By dividing the entire row by -3, then this is the pivot element. Then you make entire column. In this case we have just one more element, we make this 0, right? Then once you get identity matrix here, means this, the process is completed. On this side you get the required answer, right? Let's see how we do this. I'm gonna erase this. So we want to make this is 1, so how we make 3 1, this is the row 1, right? Now I write this and I explain you what I am doing. To make this one, I said we have to divide by 3. Then what is this R1 and R1 dash? R1 dash is the next augmented matrix, right? This is our augmented matrix. The next one that we modify with this row operation is our R1 dash. R1 dash means it's first row, so we changing only first row. R1 divide by 3. Divide this row 3 by row, divide this row 1 by 3. It is 1, then 2 by 3. No change for this, but we have to change this one. This is on the same row, so this is 7/3. We get 2, -3, -4. Clear? Okay, now this is our pivot element. This is the pivot. Right? This is the pivot. This one. Okay, then what? Then next step is we look at the column where the pivot contains. We have to make all other elements even in the pivot column 0. We have to make this element 0. The way to do is, this is row 2. You just focus on this and this pivot and this element. So if you, the next one, this is R1 dash, next one say R2 dash equal to this one we focusing only on this, but R2 means this whole thing. R2 minus 2R1. That means R2 is this minus 2 times 1, that makes it 0. Right. Every time this dash means next matrix. Just R means the current matrix. Here R means in this matrix row 1, R1 prime R1 dash means R1 in the next matrix. So here R1 R2 means R1 R2, R2 dash means this next matrix, what I am writing here. So only R2 is changing, therefore we can write R1 as it is 1 2 over 3 7 over 3. R2 is this minus 2 times this is 2 times 1 is 2, 2 minus 2 is 0. Right? Do the math. I write the answer from the book, negative 13 over 3. Here negative 26 over 3. Let me explain how to get that. What we're doing is this row elements minus 2 times this. So we did that to this. It might be clear to you how we get 0. Now let's do it to this one. R2 is negative 3 minus 2 times R1. 2 times R1 is 2 over 3. This is negative, so common denominator is 3. 3 times 3 is 9. Negative 9 minus 4 divided by 3. Negative 9 minus 4 is negative 13 over 3. That's how we get this one. Clear? Let's see another one, how we get this one. So I have to erase this one to write the next one. For that, R2 is this negative 4 minus 2 times R1 is 7 over 3. 7 over 3. Again, common denominator is 3. 3 times 4 is negative 12 minus negative 14 over 3. 12 and 14 is negative 26 over 3, which is this. Clear? Right. So you see it is a lot of arithmetic, right? Do it slowly. Understand the concept. Understanding the concept is the most important thing. Again, you definitely get this type of question in the test and also in the final, right? Therefore learn this Gauss-Jordan reduction method, right? Now we get this. Now okay, we make all column 0, then the next is go to the next diagonal element. Next diagonal element is this. We have to make that 1. So what's the easiest way to make this 1? Again, we have to change R2 dash equal to this is R2 dash means the next matrix, R2 now if you multiply this by, you focus only on this element, one element, right? This is our next diagonal element. So we want to make this 1. What we do to this, we have to do it to the entire row, but we focus only on this one. So if you multiply this by -3/13, 13 to 13 cancel out, 3 to 3 cancel out, -3 times negative is positive, we get positive 1, right? So we have to do this. Once we do that, I write the answer from the book. We get 1, 2/3, 7/3. It won't change, but this will change 0, this becomes 1, this will change to 2, right? Do the math, then you will see. It's not hard, it is just arithmetic. It is I know it's a lot of work, but it is simple arithmetic. Now we are here, right? Now are we done? We want to make this identity matrix. So only thing is this, that's why it said once you make this 1, this is our pivot now. This is our pivot. Now the pivot column is this. We have to make this element 0, right? Okay, I'm gonna erase this first line. Now what we changing R1, therefore R1 dash equal to this is 2/3. If you multiply 1 by 2/3 and subtract these two, we can make this 0. So R1 dash minus 2/3 times R1. If you multiply this by 2/3, what we get? 2/3 times 1 is 2/3, right? Then if you subtract that from this, you get 0 there. Then we get 1. When we do that, we get this element 0, this is 0, this is 1, this will not change 2. What we do to this, we have to do this and this. But why I write 1 here? When you r1 dash is 1, if you consider this element, this is 1 minus 2 over 3 times r1, 2 over 3 times r2, I'm sorry, this should be 2. We use this one, this row, 2 over 3 times r2, this part is 0 for this element. R1 prime next element equal to what I'm writing. R1 is this current one. Since I do not have space there, it continues here, right? So this thing comes on top of this arrow. R1 prime means the next matrix, this one I'm writing, equal to R1, this one minus 2/3 times R2. 2/3 times R2 is 0. Therefore, whatever we have here comes there 1, right? So we see this becomes 0. Then when we do the same thing, R1 is 7 over 3 minus 2 over 3 times this element gives us, let me get the answer from the book, we get 1 here, right? Yes. So once we do that, you see on the left side we have identity matrix. Therefore we can say that, I'm gonna erase this part, if you convert this back into matrix form, we get 1 0 0 1 x y equal to 1 1 2. When we multiply this, we get x equal to 1 and y equal to 2, right? Means after you get this identity matrix on the left, you don't even have to write this. You can directly write the answer, x is 1 and y is 2, right? This is the final answer. Okay, now I'm gonna erase this. Do another example from the book. This is in page 642. (3x minus 2y plus 7z equal to 25) 4x plus y minus z equal to 6. 2x plus 3y minus 4z equal to negative 5. Now let's write the augmented matrix. -3, -2, all the way to the left. -2, 7, 4, 1, -1, 2, 3, -4, 25, 6, -5. This is our augmented matrix. I explained the way how to do it. Now what is the first step? We look at the diagonal. This is our diagonal. Then we have to select any element on the diagonal and make it 1. I picked this question because I want to tell you this. Now in this question you see one of the diagonals already 1. Therefore, without making this one, we can select this as our pivot element. See, this is the diagonal. This is already 1. Therefore, we can pick this element as pivot element. Then what we have to do, make other elements on the pivot column 0. So you do this operation r1 prime equal to 2r2 plus 2r2 and r3 prime and r1 prime means next matrix r1 plus 2 times r2. We changing row 1. See, this is the one we changing. This is the one we changing, r3, right? So we changing row 1 and row 3 in the next matrix. That means row 2 not changing at all in the next matrix. r1 current element is 3 plus 2 times r2. 2 times 4 is 8. 8 plus 3 is 11, right? Here r1 is -2. If you add 2 times r2 is 2, 2 times 1 is 2, -2 plus 2 is 0. Here you get 5 and I write other elements here. I said the second row not changing, 4, 1, -1, 6, and third row again it will change. r3 dash means this element. How we get that? r3 minus 3 times r2. r3 is this 2. If you cannot do it by mind, write it on the side or on a separate paper. r3 is 2 minus 3 times r2 is 3 times 4 is 12. So this is what? 2 minus 12 is negative 10. What we want to do, we want to make this element 0. That you have to decide first, right? How we make this 0, that's how I write this equation. From R3 we have to subtract 3 times this. I find it is always easier writing in this way, but you can write it, you can interchange these two, it's okay. The point is this minus this element minus this times this, always, because pivot is always 1, right? This minus this times pivot gives us 0. That's how we decide to write this equation like this. 3 minus 3 times 1 is 0. Other two elements are negative 1 and negative 23. Now these two becomes 0. Then what? So I'm gonna erase this part, just show you calculation. Now we have to go back to our diagonal, which is this. This is already 1. Do not pick this one. Go to any other element, to this or this, to either one. I would rather go this one because it's easy to make it 1. We want to make this 1. What we have to do to make it 1? Multiply this entire row by negative 1. When you multiply this, you decide only from this. How we make this 1? When we multiply this by negative 1, that means we have to multiply entire row by negative 1. So that is R3 dash equal to existing one is R3. We have to multiply this by negative 1. (11, 5) 4, 1, negative 1. We have to multiply this entire row by negative 1, then it would be 10, negative 10, 0, positive 1, positive 23. Everything else should be the same. Then what? Then we have to make these two elements 0. Now you catch the way to do it. So this minus 5 times this again. Now the pivot is this. This minus 5 times this. R1 prime equal to 1 minus 5 times R3. We look at only this one and the pivot. This and pivot. This minus 5 times this makes this 0. That's how we decide. Then this one, negative 1. How we make this 0? We look at this one and the pivot. if you add these two, simply make this 0, right? Then R2 prime equal to R2 plus R3, right? Now why I ask you to look at only the element you considering and the pivot, it will not hurt these zeros that you already made. You may doubt right now, since especially for those who are doing this for first time, when you do it in this order, that's why we have this order, we have to follow this order. When we do it in this order, it will not change those zeros that you already made, right? Then we get this matrix -39 0 0 -78. Now we make the entire column 0. Then what? We again look at our diagonal. Our diagonal is this. The only remaining element in the diagonal is -39. We want to make that 1. The way is divide that by itself. Means R1 dash equal to R1 divided by -39. We have to divide this row by -39. That's the only thing. So this becomes 1 0 0. So 2 times this is equal to that. We divide by -39, therefore this should be positive positive 2. The rest should be the same. 14 1 0 29 10 0 1 23, right? Now we have this is 1. Now we can make these two zeros. What we want to change, R2 and R3. Minus 14 times R1. This is the pivot now. R3 prime equal to R3 minus 10 times R1. Okay, that gives us this matrix. I write the answer from the book. 2, 1, 3 we get here. We get, with this we make 0 here and 0 here. Then we get identity matrix here. We get 1, 0, 0, 0, 1, 0, 0, 0, 1 here. On the right side we get 2, 1, 3. So that gives us the solution, right? X is 2, Y is 1, Z is 3, right? I'm gonna erase this matrix plus matrix 2, write the final answer. So once we get this, x equal to 2, y equals to 1 and z equals to 3. This gives us the final answer, right? Okay, this, once you understand the way we writing, this is the most important thing to understand. Understand the way we do the row reduction, right? Gauss-Jordan elimination or reduction method gives us the way to do it. How to do this, how to do that gives us by this basic row operations that I wrote at the very beginning, right? So learn that. Do not try again to memorize. When you do, the way is this: do this question by yourself, right? First time maybe you make a mistake, second time maybe a mistake, third time you will get that, right? Fourth time, just for the confidence, do it. That's it, right? Okay, now one other thing, you will see, even with this, it is a lot of work. Now these numbers in this question are not too bad, but they can make it any bad for a calculator question, right? For calculator question, they can give you any numbers here. So in that, learn how to use calculator for these row operations. You can use the calculator. I show you how to do it at the end. Now, for instance, I tell you a question which gives you a lot of fractions. There are many examples in the book. Even with this example, practice using the calculator the way I'm going to show you at the end. Now let's move on. What I have next is find the inverse of matrix A. I'm gonna erase this. matrix. I tell you way to do it. You know, you guys learn already one method that's for matrix with dimensions 2 by 2. This method you can use it to any matrix. Imagine a system Ax equal to I. I is the identity matrix, right? Now do this, multiply this by okay, let's write this again. Let's multiply this by A inverse left of the matrix, left of the coefficient matrix here, A inverse this by A inverse. And here we get A inverse equal to I, identity matrix, times X equal to I times A minus is A inverse. This gives you A inverse. Now we can write this as an augmented matrix. Let me write this in a different color. This in augmented matrix form is A I. Right. This in augmented form is I A inverse. Now look at where we started. We started with this AI. We end up here, say number 2. That means look 1 and 2. That means if we could reduce A to I, the other side of the augmented matrix change to A inverse. I write it here, A I, and go to I A inverse. Right? This is from 1 and 2. Which means if we can reduce this A to identity matrix, then this identity matrix will change to the inverse matrix. You know what I mean? Convert. Convert means again that row reduction, right? By row reduction, if we could convert A to I, then I will change to A inverse, right? Let's see an example. do this one. I'm gonna erase this again. You don't have to remember or memorize or write down any of these things, but it is good to know. It is good if you know the method is this, but finally if you keep in mind this big picture in mind, that is good enough. What's the big picture? If you have matrix, we can write the write its corresponding identity matrix, and if we can convert this matrix to its identity element by row reduction, this identity element will automatically change to A inverse matrix, right? So I keep this and I erase everything else here. Okay, here it is. This is in page 643. Question 8. A is given if A equal to 3523 find A inverse. Now look at this. So we can write this. So it is in augmented form. AI, we want to write AI here. A is 35, like, let me write it apart, 35 2 3. It's augmented, I mean its corresponding identity matrix is 1 0 0 1. So do you understand what I mean corresponding identity matrix? Since this is 2 by 2 identity matrix is this. If you get 3 by 3 here, the identity matrix is 1 0 0 0 1 0 0 0 1, right? 3 by 3 identity matrix, right? You get the corresponding identity matrix. It's always square matrix here, right? So what we want to do, we want to convert this to 1 0 0 1. Then we will get corresponding inverse matrix on the other side. On here, right? We don't know yet, so I put question mark here. Right. Our intention is to make only this part here. This part comes automatically as we change this, right? So let's see how to do it. Still we do it in the same way we did Jordan reduction. We find one of the elements in the diagonal and make it 1. For instance, let's make this element 1. For that, what we have to do, this is row 1, r1 prime, we make it r1 divided by 3. You may wondering, oh, we can make both of them 1 at the same time. Don't do that. Why? Once you make this is 1, then we have to make this guy 0, right? Then when you make this 0, if you make this guy 1, it will change, right? Therefore, go follow steps. First make one of the diagonal element 0, one of the diagonal elements 1, then make everything on the pivot column 0 beside that pivot element is 1, right? So let's do this. r1 divided by 3, r1 dash equal to r1 divided by 3. So when we divide row 1 by 3, we get 1 5 over 3. On the other side we get 1 over 3, 0 divided by 3 is 0. Bottom won't change. 2 3 0 1. Now what we have to do, this is the pivot. Now we make the pivot. Now we have to make this guy 0. r2 dash equal to r2 minus 2 r1. With that we get r2, this minus 2 minus 2 times 1 is 0. We have to do the same thing to other elements too. There you see, since we do operation only to r2, r1 will not change. So I keep r1 1 5 over 3 r2 minus 2 times r1 is 0 minus 2 over 3 is negative 2 over 3. 3 minus 2 times this is 2 times 5, 3, then minus 3 minus 3 minus 10 over 3, right? Common denominator is 3, 9 minus 10. Okay, 9 minus 10 is negative 1. This is how we get this element, right? Okay, now you know how to do the row operations, I believe. If you have any questions, let me know. Use my email. Okay, now what? Now we make the entire column 0 beside the pivot element. Now we have to make this guy 1. I'm gonna erase this. make this one, multiply this with negative 3 over 1. Negative 3 over 1 means negative 3. Wait. R2 prime equal to R2 times negative 3. Right. This gives us, I write the matrix here, then this is the pivot element. We have to make this guy 0. So for that we write R1 prime, we changing on the row 1, equal to R1 minus what I said, remember, R1 minus 5 over 3 times R2. Pivot is 1, therefore multiply this by 5 over 3. 5 over 3 times R2. Okay, this gives us this 0. We get this matrix 1 0 0 1, other side okay, we get this. So once we get the identity matrix here, this is the A inverse or inverse matrix of A. Right. I can complete that here. Therefore A inverse equal to negative 3 5 2 negative 3. Right, this is our final answer for A inverse. Okay, so I explain you how to find the inverse of a 2 by 2 matrix. There is another 3 by 3 matrix example in the book. Do question number 9. Right, I'm gonna erase this. Now if once you practice, you will be familiar with these row operations. You see, it is not too hard. The method is not too hard. The only challenge is the arithmetic here. For that, use calculator. Right, you have option. Okay, I just tell you the way to do question number 9. This is in page 644. Is this 2, 3, 10, -3, -6, -8. This is A, and it's asking you to find A inverse. I tell you how to do it. Find the diagonal. This is the diagonal. Make one of the elements 1. So one of the elements is already 1, so select this one as your pivot, then make this column 0, this 2 and -3, make them 0, right, by row reduction. On the other side you should have this identity matrix. If I write the augmented matrix for the system, we have 1, 2, 3, 2, 3, 10, -3, -6, -8. Now the corresponding identity matrix for this is 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? Now start with this. The diagonal, this is already 1, therefore this is the pivot. Then make this column 0, these two. After that move on to this. It's okay you move to this, but I go rather on the order. It's okay again if you find converting these to 1 is convenient, that's fine after doing this. If not, make this 1, then entire column, this and this make 0, then go to this one, make it 1, after that make these two zeros from row reduction operations. Once you do that, you get identity matrix here, 1, 0, 0, 0, 1, 0, 0, 0, 1 here. Once you get that, on this side you get A inverse. Whatever you get here is your A inverse. You have this is your A inverse. Right, that is the method. So those row operations, it's the same. Do that, get this question done. There is a very typical calculator question next up here as example 10. Right, I'm gonna erase this, and I have a word about example 10. It is once you reduce A is a nice matrix, but A inverse is not. A is 3, 4, 2. 2, 1, negative 5, 3, 9, 0. Here, once you find by row reduction, once you find A inverse, you get A inverse as this. Over 7, 6 over 35, 35. Negative 22 over negative 1 over 7, negative 2 over 35, 19 over 1 over 5. Over 7, negative 1 over 7, negative 1 over 21. Right. Now, once you get this, you can with fractions you can leave this as answer. Right. I give you full credit for that, even for final. Right. Once you get this, leave this answer for final. But if you wanna reduce this, you can do this. You can find the least common denominator for all these fractions. In fact, it is 105. 105 you can divide with 7, 35, 21. Therefore, you can take 1 over 105 out as the common factor. Then divide this by 7, then multiply by 3, you get 45. Understand? 105 divided by 7, get that number, means 105 divided by 7, get that number, multiply 3 by that number. (15) 3 times 15 is 45. 105 divided by 7 is 15. 15 times 3 is 45. That's how you get 45 here. Rest do the same thing. 105 divided by 35, multiply that number by 6, and you get this 18, negative 22, negative 15, negative 6, 19, negative 5. Right. You may leave this as the answer or this as the final answer. Either one. You get full credit for that. Right. Okay. Next, I want to discuss about a special case. What's this example number? This is example 11. So I hope you get this. I'm gonna erase this. 1 3 negative 2 8 10 26 36 negative 36 6 11 negative 22. When you reducing this, at one instance, okay, you start getting the augmented matrix 1 3 negative 2 8 10 negative 36 6 11 negative 22, and corresponding identity matrix is 1 0 0 0 1 0 0 0 1. Right? When you keep reducing, at one point you get answer something like this: 1 3 negative 2 0 1 10 over 7 0 negative 7 negative 10. Right? And on the other side you get some numbers here. Now once you get this here, this is the pivot, right? We want to make this entire column 0. Focus on what happened when you try to do this one. To make this one 0, this is the third row, R3 dash equal to R3 plus this is negative 7. If you add 7 times this to this, 7 times R2, 7 times this to this, this becomes 0. Our intention is to make this 0, but let's see what happens. When you go to this element, negative 10 minus 7 times R2 is 10 over 7. Then this to this cancel out. R2 R3 plus 7 over 2, this is plus this 7 to 7 cancel out, negative 10 positive 10, you get 0 here. That means you get 0 here, unintentionally you get 0 here too. That is the special case I wanted to discuss. I write only that part. 0 1 0 dash, you have the other side. Oh, wait. No, you get zeros here. At these two places you get zeros, right? Now you hear what I'm saying? Now here we do two operations to make this 0 and make this 0. To make this 0, you do R1 prime equal to R1 minus 3 times R2. Right? When you do this operation, it is fine, you get this line, but when you do this operation, our intention is to make this guy 0, but when we do this, it makes both these zeros. Oh, this is already 0. Understand? So this was already 0, so this is 0. It makes this 0 and this 0. Then what we going to do? Right? Now I'm gonna write that matrix on the top. We get 1 0 16/7 0 1 10/7 0 0 0. On the other side we get 0 4/7 negative 1/14 0 2 negative 1/2 1. We got this, right? This is here. Now this is 0. That means we if we could make this is 0 and this is some number here, in our next step we try to divide this by itself and make it 1. In this case we cannot make this 1, and therefore we cannot make a pivot. That is 0, because we cannot make this 1 dividing by anything, right? Therefore we cannot make a pivot. Since we cannot make a pivot, we cannot make these zeros. If we could make this 1, next step is make this is 0 and this is 0. Since we get this 0, we cannot make these two equal to 0. So this type of thing, if you get zeros in one of the rows, whole row, we call that is a singular matrix. Because of this, we say therefore A is a singular matrix. Therefore A has no inverse matrix, no A inverse, right? That's our final answer, no inverse matrix. Understand? In any question, in any case, if you get entire row equal to 0, that is a singular matrix that has no inverse matrix. Okay, that's all I have for appendix 3, but there are some calculator tips I want to tell you. I'm gonna erase this. Mainly there are three calculator operations I want to highlight. It is in the book 2. This is in page 646. One is this row swap. AMN Okay, now first of all, this arrow means the store symbol on your calculator. Let me see. Yeah, this one. It is STO, that one. Now row swap means it swaps M and N rows. If you want to swap, means interchange. Swap means interchange. First and second row, you write A1, 2. A is the name of the matrix. Right? I showed you how to create a matrix on the calculator last time. A is the name that you gave to the matrix. Here you type those two rows that you wanna interchange. Let me tell you, this relatively less important compared to these two, right? Very rarely I use this operation, but we need these two. M row means multiply row, MAR. A is the matrix, Okay, here is the matrix. This multiplies these two. If you want to multiply m and r, here you write, wait, row multiplies row r by of the matrix A by constant m, and it was this new matrix, right? If you want to multiply a row by a constant, this is the command mrow. First of all, these things in catalog. You see this key catalog. That one, right? Under that you can find these commands, or you may type this. You can type letters using alpha key and the corresponding key, the relevant key. So you may type it, and the easy way is go to catalog and you can find the command as it is. So this means multiply this row by a constant m, right? That's a useful one. This means m row at okay, this one multiplies these two multiplies, and the resultant you add with this matrix plus this, add it to this, means you first multiply these two and add it to row j. This row I multiply with the constant and add it to j, and it stores in j, right? You remember we use this type of thing, multiply these two and add it to j and stores it at the place of j with row j, right? So use these two, and if you want, use this one too. Use these row operations with your calculator and do at least a couple of questions. You will familiar with that definitely in the next test, and also in final you will definitely get these type of questions, and to use the calculator too, right? So that's all I have for today. This is multiplication. This is all I have for today. So please practice those questions. How you practice? Get a piece of paper, write down those questions I did. First write it down, then try to do it by yourself. Maybe you make mistake. Do not discourage with that. Second time, third time, then you will be successful, guaranteed. Then do it for your confident for another time, right? So take care and stay safe, guys, right?